For a function y is equal to y is equal to fx, the way to find the maxima and minima, local maxima and local minima, what we do is we look at the gradient of tangent, the slope of tangent. So basically the slope of tangent, gradient of tangent is given by y prime, and this is check at any point the gradient is calculated, and what happens is at maxima or minima the gradient becomes 0. So that is called a stationary point, and then we have to know whether that stationary point is a maxima or minima. So let's say we don't have the graph, we just have a function, just as a, let's say y is equal to x square, just as it is. So the maxima and minima, to find it, first the gradient is calculated. So in this case it will be 2x, the gradient of tangent, and then the stationary point the y prime will be 0, because gradient of tangent will be 0 at the stationary points. Now the second thing comes whether that's a maxima or minima. So there are two methods. One method is just taking that point, let's say x is equal to a. So what is the point, what is the, at that point this is the stationary point. So what we do is we just have, so we have x is equal to, say stationary point is at a, that's x there, and this is y prime. So what is the gradient just a little to the left and little to the right. So if the point is say 1, we have to check what is the gradient of tangent at 2 and say 0. And if this one is a positive, that means the gradient is like that. And if this one is a negative, that the gradient is like that, then this stationary point is a maxima. So if we do with this function, this has a stationary point 2x is equal to 0. So at x is equal to 0, this has a stationary point. So if we want to find the whether this is a maxima or minima, we can do x is equal to 0, x is equal to -1 and 1. What are the y prime values? So y prime is 2x. So at x is equal to -1, this one is a negative, and here of course this is a stationary point, this is the stationary point, and this one when x is equal to 1, this value is a positive. So this is 2 and that's a positive, and this was -2. So the gradient here is like that and the gradient here is like that. So this point is a minimum. So this is one way of finding whether a point is maxima or minima. And then there is another way, is looking at the second derivative. And for some curve, let's for this function, the second derivative does not have any x, so we shouldn't apply that one, this here. So if the second derivative exists, then what is done is the second derivative is calculated. The first derivative is of course f prime x, which gives the stationary point. That means when the first derivative is 0, and then what happens is, to know whether this stationary point is a maxima or minima, the sign of second derivative at that point is calculated. So what is the sign of second derivative? If the second derivative is a positive at that particular stationary point, then this one is a minima. And if the second derivative is negative, then this one is a maxima. And that happens because of the curvature, which I will discuss in the next video, whether it's for the concavity, so whether it's concave up or concave down. But this is the rule. If second derivative exists, then we find the second derivative at the stationary point when the first derivative was 0, and if the second derivative is positive, that's a minima, and if it is a negative, then that's a maxima. And one thing is, we can apply both. First of all, if the second derivative exists, we find the second derivative, but sometimes the function is we have to look at the function whether it's easier to find the apply this rule. So just finding the what's the sign of first derivative just to the left and to the right. If that is convenient, we apply this one, or if finding the second derivative is more convenient, then we do apply that one. Whichever is convenient, we can use that depending on a particular function that's given. So yeah.